All right, so in this video, we're going to actually go through both empirical and molecular formulas, so it is going to be a little bit lengthy. We're going to do the empirical formula piece first, followed by the molecular formula piece. So, empirical formula is the smallest whole number ratio of elements in a compound. So, the smallest way that two or more elements can come together to form a legitimate compound would be what we see as an empirical formula. So, how to calculate empirical formula? So, if you will think to the tune of Jingle Bells, this is a little song for you to help you remember your steps. So, I will say it for you. I'm not going to full out sing. No one needs that immortalized on the internet. The rules of how to write your empirical formula. So, think Jingle Bells. So we go percent is grams, grams to mole. Now you're on the way. Divide by the smallest and round to the whole. And now you've got an A. Hey, right? So percent is grams, grams to moles. Now you're on your way. Divide by the smallest, round to the whole. And now you've got an A. Or really what you have is the empirical formula. So let's talk through each of these steps. Percent is grams. So you're either going to be given a percent composition, or you'll be given grams. If you were given a percent composition, we assume that the percentages add up to 100 and would therefore represent 100 grams. And so we would convert the percent to grams by literally just changing the percent sign to a G for grams. If you're given grams, then we assume, well, this is all we have in our formula or our compound. And so we just use those grams. Grams to mole, so divide by the molar mass or the atomic mass of that particular element. When you're converting from grams to mole, you're going to ignore your diatomics because you're in a formula, so they're not diatomic. They're only going to be diatomic if they're by themselves, which they're not going to be here because, again, they're in a formula. Once you have your number of moles, you're going to look at the moles of each element. Whichever one is the smallest, you're going to divide all of the moles by that smallest number, because what you're trying to do is to create a ratio between the elements. So you divide by the smallest one, and that's going to generate a number. And hopefully those numbers are whole numbers. If they're not, we have to consider how to round. Now, on this note about rounding, these rules on rounding are intentionally simplified. This is for honors level chemistry. If this is AP chemistry, the rules are going to be different. So just know, those of you that are going to go on to take AP, this is not the whole story. These are intentionally very simplified. And you will get the other half of this when you take AP Chem. So here are your rules for rounding. If your decimal ends in 0.0, which would be a whole number, so it really should be 0.01, between that and 0.44, you're going to round down to the nearest whole number. So if it's like 2.25, you round down, you call it 2. If it's 2.44, you round down, you call it 2. Okay. If the decimal is between 0.56 and 0.99, you round up. So 2.56 becomes 3. 2.38 becomes 3. But in that middle section, 0.45 to 0.55, we can't just round. So we have to multiply by 2, and you're multiplying everything by 2 because you have to maintain the ratio. So I can't just multiply one of them by 2. I have to multiply all of them by 2. Okay. So again, this is oversimplified. In AP, there's a little bit more multiplication involved instead of the rounding down and the rounding up that we see here. But for you guys, for Honors Chem, this is sufficient. All right, so let's look at our first problem. Determine the empirical formula for a compound that has 75% carbon and 25% hydrogen. So it's a formula only of carbon and hydrogen. So our first step in our song is percent is grams. So I'm going to take this from 75% of carbon to 75 grams of carbon, from 25% hydrogen to 25 grams of hydrogen. So percent is grams, check. Now grams to mole. I need to turn these into moles. So I'm going to multiply by 1 mole of carbon over the molar mass or the atomic mass of carbon, which is 12.01. And I'm going to do the same thing for the hydrogen. This is basic stoichiometry, which is what we've been doing, 1.008. okay? And that's going to give me the number of moles because my grams are going to cancel out. So when you are writing down your number of moles, sig figs are not important here because your final answer is going to be a formula, but you don't want to short yourself decimal places because if you short yourself decimal places, you might not necessarily determine the smallest thing correctly, or when you divide by the number, you might not get the smallest or the correct ratio. So what I recommend is when you're writing this down, you're going to go at least 3 decimal places. Okay, so for this one, 6.245 would be at least 3 decimal places. You could go out more, but I feel like it's a little bit unnecessary. All right, then 25 divided by 1.008, again, to 3 decimal places, 24.802. All right. So percent is grams, grams to mole. Now you're on your way. Divide by the smallest. So you look at these two numbers. Which one is smaller? Obviously, it's the top one, 6.245, 6.245. Divide by the small. So this is obviously going to be 1. And then 24 divided by 6, we're probably looking in the neighborhood of 4. So let's see. I'm going to select this one. My answer here, divide by this guy. 3.97. All right, so percent is grams, grams to mole. Now you're on your way. Divide by the smallest. Check. Round to a whole. This is already a whole. 0.97, that's going to fall in this section of 0.56 to 0.99, so we're going to round up. So this is going to be 4. So that means my empirical formula is CH4, which that should make sense to you based on what we've done with nomenclature and making compounds. That, yeah, carbon makes 4 bonds, bonding with 4 hydrogens. That should check out. All right, so let's do another example. So we're going to just do the same thing in terms of our steps. Determine the empirical formula for a compound with 22.1 grams of aluminum, 25.4 grams of phosphorus, and 52.5 grams of oxygen. So we don't have percent this time. So we're just going to go and use these numbers of grams. And the first step in this time will be going to moles. So 22.1 grams of aluminum, 25.4 grams of phosphorus, and 52.5 grams of oxygen. Okay, so percent is grams, we don't have to do grams to moles. So 1 mole of aluminum over the molar mass of aluminum. So on my periodic table, my molar mass of aluminum is 26.98. So 26.98 grams. Then 1 mole of phosphorus over the molar mass of phosphorus, 30.97. And then 1 mole of oxygen over the molar mass, which we know of oxygen, 16.00. Okay, so 22.1 divided by 26.98, 0.819. 25.4 divided by 30.97, 0.820. And 52.5 divided by 16.00, 3.281. Okay, so percent is grams, we didn't have to do grams to mole, so we have our moles. Divide by the smallest. So the one for aluminum is going to be slightly smaller, and you should realize right away that that's going to be 1 and 1, right? So the only one we really have to look at is that last one. So I'm going to take my mass there, and I'm going to divide it by the aluminum mass. And that's going to give me 4. All right, so what is my empirical formula? My empirical formula has 1 aluminum, 1 phosphorus, and 4 oxygens. So AlPO4. And again, that should make good sense. We know aluminum is +3. We know phosphate is -3. AlPO4 is aluminum phosphate. That seems to be the most reasonable way that those elements would go together. All right, so our last example of empirical, we have another one with a compound. So determine the empirical formula for a compound with 2.16 grams of aluminum, 3.85 grams of sulfur, and 7.68 grams of oxygen. So we can, again, skip that percent to gram step and just go for the grams to moles. So 2.16 grams of aluminum, 3.85 grams of sulfur, and 7.68 grams of oxygen. All right, so 1 mole of aluminum over 26.98 grams of aluminum, 1 mole of sulfur over 32.07 grams of sulfur, and 1 mole of oxygen over 16.00 grams of oxygen. All right, 2.16 divided by 26.98 gives me 0.0800. I'm going to go an extra place just because of that leading zero there. It's probably okay if I don't, but erring on the side of caution. 3.85 divided by 32.07, 0.120, and 7.68 divided by 16.00, 0.48. And that comes out even, so I can just leave it that way, or I could throw 0 on the end. Now, percent to grams, we didn't have to do. Grams to mole, check. Divide by the smallest. So the aluminum is the smallest, 0.0800. So we know the top one's going to be 1. And then for the sulfur, we're looking at 1.499. And then the last one, 0.48 divided by 0.0800 gives me 6. Okay, so 1 and 6 are nice whole numbers. This is not a roundable number, right? 0.45 to 0.55, I've got to multiply everything by 2. So 1 times 2 is 2, and 6 times 2 is 12, and 1.5-ish times 2 is 3. So my empirical formula, Al2S3O12. Okay, that's fine, but what should you be able to recognize here? This is aluminum, S3O12. It's probably going to be reducible. This is a polyatomic ion, right? So Al2SO4 3. Will I take this as a right answer? Yes, all day long. Is this a better right answer? Absolutely. What you need to note here is you can only do this if you have a legitimate polyatomic and it's connected to something else, right? OH by itself, you can't just put that in parentheses and shove a subscript on it if it's not connected to something else. So I can do this because I have a polyatomic and it's connected to something else, so it is behaving as a polyatomic. All right, so that's it for empirical. So now we're going to move into molecular. And the thing with molecular is that in molecular, the first step is to find the empirical formula. So molecular is the actual whole number ratio of atoms in a compound. Sometimes the empirical and molecular formula are the same. Sometimes they're not. It is a multiple of the empirical formula. So that means we have to find the empirical formula first unless it's given. So let's look at our steps. First, find the empirical formula. So everything we just did in our little Jingle Bell song, that's your empirical formula. Second, determine the molar mass of the empirical formula. So once I get the empirical formula, add up the atoms of each element, get a total mass. Divide the molecular formula molar mass. So you're given this in the problem, you need to divide that by the empirical mass that we calculated in step 2. And that's going to generate a multiple. That's going to tell me how much bigger the empirical or the molecular formula is than the empirical. And then multiply the empirical formula by the multiple. Okay. So we're going to look at, I think I have slated 2 examples. Yep, 2 examples of this. All right, so find the molecular formula for a compound that's 40% carbon 6.7% hydrogen, and 53.5% oxygen if the molecular mass is 60.0 grams per mole. So the first thing we need to do, step one, find the empirical formula. So percent is grams. So 40.0 grams of carbon, 6.7 grams of hydrogen, and 53.5 grams of oxygen. Okay. 1 mole of carbon over 12.01 grams, 1 mole of hydrogen over 1.008, got ahead of myself, grams, and 1 mole of oxygen over, now it's time for 16.00. All right, so we need to get our moles. So 40.0 divided by 12.01 gives me 3.33. 6.7 divided by 1.008 gives me 6.64. And 53.5 divided by 16.00, this was 3.330. And this was 0.7. I shorted you some decimal places, and that is not very kind of me. All right, there we go. All is right in the world. So percent is grams, check. Grams to mole, check. Divide by the smallest. So our carbon is going to be the smallest, 3.330, 3.330, 3.330. Obviously this one and that one are both going to be 1. So 6.647 divided by 3.330 should be, 1.99, so 2. So my empirical formula is CH2O. Okay, so now I need to get the empirical mass. So that means I'm going to add up the molar mass of this compound. So 12.01 plus 2 hydrogens, so 2 times 1.008 plus 16.00. So 12.01 plus 2.016 plus 16.00, 30.026. All right. So now this is my empirical mass. I was given in the problem a molecular mass. I'm going to divide the molecular mass by the empirical mass to generate a multiple. So hopefully you see where this is going. 60 divided by 30.026. I bet this is going to be 2 or close. It is. And that means that my molecular formula is 2 times the empirical. So multiply this by 2. So C2H4O2. And that's my molecular formula. So really all you're doing is finding the empirical, adding up the mass, getting a multiple, and multiplying the empirical. It's really just empirical plus like 2 steps. All right, let's do one more of these and then you should be good to go. All right, so a compound is 54.5 grams of carbon, 9.1 grams of hydrogen, and 36.4 grams of oxygen. The molecular mass is 220 grams per mole. Find the molecular formula. So first thing again, we got to find empirical formula. So carbon, 54.5 grams of carbon. And then we have our hydrogen, 9.1 grams of hydrogen. And we have our oxygen, 36.4. And the easiest way to do this is just take them in the order that they're given and use them in that order. So grams to mole. 1 mole of carbon over 12.01 grams of carbon. 1 mole of hydrogen over 1.008 grams of hydrogen. 1 mole of oxygen over 16.00 grams of oxygen. All right, 54.5 divided by 12.01, 4.538, 9.1 divided by 1.008, 9.028, and 36.4 divided by 16.00, 2.275. All right, so now I've got my moles, divide by the smallest. Obviously, the oxygen moles are the smallest. The bottom one is 1. All right, let's see what the top one's going to be. 4.538 divided by 2.275. 1.99, so 2. 9.028 divided by 2.275. 3.96, so 4. So that means my empirical formula here is C2H4O. All right, so now I need to find my empirical mass. So 2 times 12.01 plus 4 times 1.008 plus 1 times 16.00. So let's add those up. Let's see. 2 times 12.01 plus 4 times 1.008 plus 16.00, 44.052 is my empirical mass. So my molecular mass given in the problem was 220. So 220 divided by 44.052. Where does that get me? So 220 divided by 44.052. 4.99, so 5. So that means my multiple is 5. So I'm going to multiply my empirical formula by 5 to get my molecular formula. So my molecular formula is, let's see, C, 2 times 5 is 10, H, 4 times 5 is 20, and O, 1 times 5 is 5. C10, H20, O5. All right, go forth, find formulas.